solving compound inequalities. You need a piece of loose leaf paper. The title will be Video 11, Solving Compound Inequalities. And you also need to have your textbook handy and open to page 134. Because I'm going to work through some of the examples in the reading part of the book. These are not the exercises at the end of section 2.6, but the explanation examples along the way. Starting with the first example on page 134. Now you can just watch the screen for a minute and then look at the book in a few minutes. The pH level of swimming pool water should be between 7.2 and 7.6 inclusive. pH level is a number that represents a level of acid versus alkaline composition of a liquid. But it doesn't matter what it is. You're just looking at the numbers. So this is an example, a real-life example that would be used in a chemistry class. So on your number line, we've got 7.2 right here and 7.6 here. And all of the numbers that would make that true so that you have a good pH level in your pool are in between 7.2, that's the low end, and 7.6. Now the word inclusive means that those points are also included. If you are right at 7.2 or as high as 7.6, then the pool water has the appropriate pH level. The way that could be represented on an inequality statement is, here, let's use W for water. 7.2, W in the middle, 7.6, going from least to greatest. This is called a compound inequality. It just means that the numbers, all of the numbers that are true, are in between 7.2 and 7.6. And I must remember to put a little line there because these are inclusive. On your number line, then, that means you have a dot at the low end, another dot here at the high end, and you fill in all the numbers in between. I want to make it nice and heavy here so you can see exactly what's getting filled in. That's a compound inequality where all the numbers satisfy both conditions. We only want the numbers that are more than 7.2 and less than 7.6. Now, if you notice on the example in the book where it's written out, they do an arrow going this way from 7.6, and then an arrow here at 7.2 and going to the right. And all of the solutions are in the area in between. Try the check it out question on top of page 135. So take your paper and on top of page 135, you'll see a check it out question. Try to solve that one and graph it on the number line provided. Now, if you're concerned that you're not doing it right, make a good effort, look at it, see if it fits, and we'll go over this one in class tomorrow. All right, so a compound inequality that has the word and means numbers that satisfy two conditions. Now, for example, for a grade to be failing, it has to be between 0 and 70. And I've written the inequality statement right here. Failing grades, we don't want those, are anything 0 or greater, up to but not including 70. So on the number line, I would put a filled-in dot at 0 and an open circle at 70. If you hit 70, you're passing. But the failing grades are the ones in between 0 and 70. You will not get a grade less than 0, so there's no need to include negative numbers on the number line here. So there's another example of an and inequality. And means numbers that are both more than 0 and also less than 70. I really should have said 0 or greater. All right, a B then would be grades that are 85 and above, 92 and below. That intersection. These do not go on forever, because if you start here at 85, that would be halfway between 80 and 90, and you go up to 92, which would be about right here. A grade of a B is all of these numbers in between. So there's another example. Once you pass 92, you're into the A area, all the way up to 100, the highest possible grade that will go out on a report card. All right, if you have to solve a compound inequality, you're basically going to follow the same steps that we did for equations or for the inequalities that go on forever with the arrows at the end. But instead of saying we're going to do something to both sides, we're going to say all 3 parts. Now, in the book, this is example 2, part A. We just have to turn the pages to see where it is. I'm not sure which page. But here's an inequality right here that needs to be solved, because x is not by itself. The way they work through this example for part A, it's not my favorite way to do it, but I'll show you. Some people prefer this, and it's okay if you solve this way. They like to break it up. You're saying, all right, so 4 is less than or equal to x plus 2, and you get this side right here. And then you also say x plus 2 is less than or equal to 8 right over here. To get x by itself, I'm going to subtract 2 from both sides. It's a one-step inequality when you break it up like this, so the only thing you have to do is subtract 2 from both sides. All right, and then over here, once again subtracting 2 from both sides. Now remember, we're looking for the intersection, not numbers that are where 2 is less than the number or the number is less than 6. Excuse me. So on my number line, let's say we got 0, 1, 2, 3, 4, 5, 6, and I'll go on 7, 8, 9, have a few more points here. This really means 2 is less than or equal to x, which is less than or equal to 6. All I did was take this inequality, subtract 2 from all 3 parts. That's how 4 became 2. X plus 2 became x, because I took 2 away. And 8 becomes 6, because I took 2 away there also. Now, let me get these out of the way, because they're just making a mess here. And then on the number line, I want 2 right here with the filled-in circle, 6 right here with the filled-in circle, and all the numbers in between. So here's the final answer as an inequality statement, and up here it is on the number line. Let's do one more. Now look at this one. I'm not going to split it up. I'm going to make my eyes look straight for the variable. Here's the variable. It only is in one place for this. Now what's happening to the x? It's being multiplied by 2, and it's having 3 added to it. So we're going to do the inverse, starting with subtracting 3. But instead of saying both sides, I'm going to say I have to subtract 3 to all 3 parts. Subtract 3 from all 3 parts. But just look at one part at a time. -5 minus 3 is -8. Less than or equal to 2x, which is less than 9 minus 3, 6. Now once again, I wish you could see that my eyes are focused right here. I want to get the variable x by itself in the middle. So I've got a 2 next to it. That means 2 times x. Inverse operation would be divide by 2. Negative 4 is less than or equal to x, which is less than 3. Remember, I divided by a positive number, so I don't flip any inequality signs. On the number line here, let's say I have 0 here and negative 1, 2, 3, negative 4. 1, 2, 3. X is all of the numbers in between. Just like in this statement, X is in the middle. I need one more thing. Because this sign right here is less than equal to, I'm going to fill that one in. So you can have a compound inequality with a dot in one place, right here, and an open circle in another one like this. So take a minute, take a look at that, pause the video if you need to. Now on your paper, do the check it out problems, 2A and 2B on top, or somewhere on page 135. And when you finish those, restart the video right here. All right, inequalities with the word or in it. Now this is different. We're going to put two separate groups together on a number line. Now for example, if let's say I wanted to form a group in the class and I wanted to put all of the A students in a group with all the students who are failing so that the A students could help students whose grade are below 70. So I have a number line here showing some of the grades you can get, as always, increasing as you go to the right. And I'm going to put an open circle at 70. And which way are the failing grades? They go on in that direction. And since I don't know what the lowest grade a student has in this case, I'm just going to let the arrow go on forever. And with the 93, including 93, I'm going to put a dot right here. Now I realize that we've said the grades can, it would end at 100, but just to use an example of what an or inequality looked like. And a student told me one time, well, this is kind of sad, but if you think of the word divorce, it has an OR in the middle. What happens when people get divorced? Well, they go their separate ways, and that's what happens on your number line. Maybe that'll help you remember. So when you're solving an inequality that's a compound inequality with the word or I really like the word disjoint, because that is a word that means they're separated. When I work on one side, I don't care what's on the other side. So I just solve this. It's a one-step inequality, like I would any one-step inequality. A is greater than 5. As always, when A is by itself with a coefficient of positive 1, I have that part. And when I'm ready to solve the other side, I don't care what I had over here. I just solve it. Add 4, add 4. A is less than 1. All right? So on my number line, I know that I've got a 5 on the left over here and a 1 on the right. Don't worry about that. Your number line, you should still go from smaller numbers to bigger numbers as you work left to right. And since I have a transition point at 5, I'm going to put a circle here, and it will not be filled in because this is a strictly greater than sign. Now, where are the numbers that are greater than 5? Well, they go this way. For example, 8. If I put 8 into the original inequality, you'll see that I get a true statement. 4 is greater than, 4 is greater than 1. So I've graphed this part right. Over here, A is less than 1. Okay? So here's 1. And all the numbers that are less than 1 are that direction. A is less than 1. Here's a disjoint inequality going separate ways. That's an OR inequality. Here's another one, and I'm going to move faster, but you can pause as much as you like. All right? So there is no number in the world that is both less than 3 and greater than 4. We're putting two separate sets together. Here's 3. X is less than 3, so I want numbers that are less than 3 shaded in here. X is greater than 4, so an open circle at 4, and I want numbers that are shaded in over here. Disjoint. If you see OR, think divorce. On your number line, they're going their separate ways. So that leaves 2 check it out problems for you to do. Try those, please. And I'm running over time, but I can do some additional examples. I'll just go a little quicker. All right, here's an OR inequality. So I know I'm going to get something that has an arrow going that way and an arrow going this way. All I did was subtract 8, so my inequality sign does not flip. I'll subtract 8 over here too. All right, on my number line, let's say -6 is right here. 5, 4, 3, 2, 1, 0. And then 1, 2, I'll just fill in a couple of numbers here. Don't have to write them all. But any numbers you put on the number line should increase as you go from left to right, that direction. All right. Once you have x by itself in each part, you're ready to graph. X is less than -6. X is greater than -1. That's greater than equal to. Go that way. All right, another disjoint or divorced inequality. So I've got, let's say, 1, 2, 3, 4, 5, 6, 7. X is less than or equal to 5. And look at the numbers I'm shading in. Numbers like 1. 1 is less than or equal to 5 for a test value. Numbers that are greater than or equal to 7 go this way. Numbers like 10. 10 is greater than or equal to 7. Here's another one of the compound inequalities. Just like x is in between numbers here, x will be shaded in between on your number line, and you don't have to worry about any arrows. But look in the middle. The first thing you do is subtract 1, but now we're doing it from 3 parts. I want x completely isolated in the middle, so divide by 4. But if you divide in one place, you have to divide in all 3 places. So x is between 1 and 3. I'm going to spread these out a little bit. Let's say 1, 1.5, 2, 2.5, 3, 3.5, 4. That would put 0 right here. I'm just putting the numbers on top because it's a little crowded. All right, so I have a filled-in circle at 1. I have an I have a filled-in circle at 3 also. The numbers that are in between 1 and 3 are shaded in here. So we've gone about 20 minutes there. Sorry that it ran a little long this time, but look through the reading, and I'm not going to make a bookwork assignment at this time. I just want you to watch this video, try the examples that we have, and then be ready to come in tomorrow to practice for the weekly test on solving inequalities.